The topic of this lecture will be the addition of halogens to alkynes. The mechanism of this reaction for the addition of halogens to alkynes is very similar to the mechanism for addition of halogens to alkenes. However, because we have two pi bonds, we can have the addition of 2 moles of the halogen to the alkyne. Addition of 1 mole of the halogen to 1 mole of the alkyne yields both the cis and trans isomers of the addition product. Addition of the halogen to the pi bond likely occurs similarly to the way that it occurs in the alkene, with the pi bond acting as the nucleophile and the halogen acting as the electrophile. The pi bond attacks the halogen, kicking off the leaving group to form the halonium ion. Attack of the halide ion then occurs from the opposite phase to give the trans isomer. However, we also often observe a fair amount of the cis isomer as the product. There is still some disagreement in the chemical community about how the cis isomer is obtained, but it likely has something to do with the fact that this halonium ion with a pi bond is considerably more strained than a halonium ion that only has a sigma bond between the carbons. Remember that the halonium ion, in all cases, has several resonance structures. It is likely that the actual structure has a significant more character of these 2 additional resonance structures, meaning it has more carbocation character, and this is likely how we lead to the cis isomer as well as the trans isomer. However, in most cases, it is difficult to stop the reaction of the addition of a halogen to an alkyne after the addition of 1 equivalent of the halogen. Typically, the alkene then reacts again to form the tetrahalogenated product. There is no stereochemistry in this final tetrahalogenated product. Now let's look at an example. If we treat this alkyne with bromine, we will get a single product. Because the alkene that is formed as an intermediate is even more reactive towards the bromine, it is impossible to stop this reaction at the alkene intermediate. Instead, we get the tetrabrominated product.